Even if you do come back, it still does just that's what I would do.
I learned more.
Today we're gonna start into chapter 2. When dealing with chapter 2, chapter 2 deals with a lot of equations with lines, functions, the idea of functions, parallel, perpendicular lines, so on and so forth. We start dealing with what is called a coordinate plane. The idea of a coordinate plane, and this is something that should be reviewed for you, but we'll continue to enhance what we've done, like we do everything else. When we're talking about a coordinate plane, it's a two-dimensional number lines. Two-dimensional number lines. When working with a coordinate plane, you're looking at two-dimensional number lines. Two-dimensional number lines. These number lines, what do we call the number lines? What do we call these number lines? We have a vertical one, we have a horizontal one.
You're like a key in my office.
Jalen was able to get back in.
That's right. What'd you say?
Jalen was able to get back in. I guess you should have kept the door open for me. What do we call the number lines?
Axes.
Yeah, the axes, that's correct. Typically, we will call this the x-axis and the y-axis. We have the x-axis and we have the y-axis. These are the number lines. The two number lines. Okay, they intersect at a point. That point's called the what, Jack? The origin, that is correct. So we have the point of intersection. This is the origin. And our coordinate plane is divided into 4 regions now. Okay, the plane is the plane of the board. Okay, a plane is a flat surface. When we're talking about a flat surface, our flat surface is our smart board there. That is the plane. We divide these into 4 regions. These 4 regions are called quadrants. Quad means 4. Quadrants, 4 regions. Question is, how do we number these quadrants? Mason, how do we number these quadrants? You remember? Top right is number what? Okay. So we have top right is Roman numeral 1, then Roman numeral 2, then 3, and 4. That is correct. So we start in the upper right, the positive quadrant for x and y, as quadrant number 1. Then we go counterclockwise in regards to numbering 1, 2, 3, and 4. Once again, this is all terminology that you should be somewhat familiar with. We talk about an ordered pair. An ordered pair signifies a location on the coordinate plane. Ordered pair signifies a location. Location, location, location on the coordinate plane. It signifies a point. So when you're talking about a location, you're talking about a point. So you're talking about a point. Typically, we're going to deal with the x-axis as horizontal and the vertical axis is the y-axis. That's typically what we will do. We also can classify these as independent and dependent variables. The independent variable is a variable that's substituted in for into an equation. Typically, this is the horizontal axis. It is typically your horizontal axis. Horizontal means side to side, laying side to side. That's your horizontal. Most of the time it is the x variable. We will use the x variable, but sometimes we will use, and when you're talking about physics and science, it will be in your time. You'll use the variable of time down there as your horizontal axis or your independent variable. The variable that you substitute in for as your time. We also have the dependent variable. It is the variable that's solved for in an equation. It is dependent on what you substitute in for the independent variable. This is typically the vertical axis. It is your typical vertical axis. What we're going to work on today is we're going to work on distance between 2 points and midpoint between 2 points. Okay? And in one-dimensional situation, which means just looking at horizontal or vertical, this is not a very difficult thing to do. If I take a look at the order or the values at 4 and -3, when I'm looking at a midpoint, hopefully we understand what a midpoint is. The point that is directly in between two other points. If I have the value of 4 and -3, what is the midpoint between the value of 4 and -3? What's the halfway point between 4 and -3? Oh, 0.5. How'd you come up with it? What would your mental madness that took you to 0.5? It's correct, but what's the mental madness? You counted what? Okay. Okay. He went, and this is a typical way of doing it. We're going side to side. Okay. We count in from here. We count in from here. We count in from here. We're at 0.5. That is fine. That's one way of doing it. Anybody have another method of madness? Add them together and divide by 2. The games of halves, our trig ideas. Add two numbers together, divide by 2, and trying to find the middle number between two different numbers. Add them together and divide by 2. And that's another way of doing it. So I can take 4 plus -3 and divide that by 2. And I get the value 1/2. What's the midpoint between -6 and 2? Go ahead and find the value. Check your answer with somebody around you. Sarah, what did you come up with? Which one is it? -2. Okay, -2 is a midpoint. Well, what happens when we turn this into a second dimension now? Two-dimensional. I have the ordered pair 1, 2, and the ordered pair 4, 6. So make sure we label our axes. X is 1, Y is 2. There's my ordered pair 1, 2. Then my second point, my second ordered pair is X is 4. And Y is 6. So I have the ordered pair 1 and 2 and 4 and 6. Question is now we are at an angle, how do I find the midpoint? Because now my segment that I'm dealing with is this segment right here. How do I find the coordinate pair or the ordered pair of that midpoint? Okay, a little bit different. When I'm talking about just linear, horizontally, and vertically, it's easy to do. But now when I start dealing with an angle, we have to deal with a little bit different aspect. But if we take a look at a different aspect here, let's change the idea of this to horizontal and linear, or vertical. And let's take a look at what happens here horizontally. Horizontally, we are starting at the value of 1. And we're moving to the value of 4. What is the halfway point? What is the midpoint between the values of 1 and 4, Todd? 2.5. So at the value of 2.5, this is our midpoint. If we take a look what happens vertically, I'm going from the value of 2 up to the value of 6. What is the halfway point between the value of 2 and 6? Amber? The value of 4. Bless you. The value of 4. Now, if we take a look at these coordinates and take them across and take it upwards. Not a very good picture there. There we go. And we look at this one point. This one point is going to be the midpoint between the angled line or the angled segment there. So this ordered pair of 2.5 and 4 is also our midpoint. So what we have done is rather than look at this as an angle, we've reduced this down to a horizontal and vertical components. And we look at horizontally and vertically, what's the midpoint going to be? Now what we could do with respect to just looking at the coordinates here is, yes, we could draw a picture each and every time, but that's a lot of work. Let's just take a look at the process here. Okay, I'm looking at the x values of 1 and 4. What's the midpoint between 1 and 4? Well, I could take 1 plus the 4 and divide it by 2. When I'm trying to find the middle number between two numbers, add them together, divide by 2. Game's a half. If I take a look at my y values, I have 2 and 6. My y values are 2 and 6. So I can add 2 plus 6 and divide by 2. And we'll come down to our ordered pair of 5 halves and the value of 4 as the midpoint. So when dealing with the midpoint, we can just take our x average values, our average of our two x values, and our average of our two y values. You go ahead and try it. We have 4, 6, negative 2, 1. What's the ordered pair of the midpoint? Check your answer with somebody around you. Kindly would come down to. I'm sorry, what? 1 and 3.5. That's correct. We can take the 4 plus negative 2 divided by 2 and 6 plus 1 divided by 2, and we can get our ordered pair for the midpoint. Take a look at the distance between the 2 points. I have the values negative 4 and 3. What's the distance between those 2 points? I have a value of negative 4. I have a value of 3. What is the distance between those 2 points? The value of 7. How'd you get 7? Did 4 plus 3? So you took, these 4, 1, 2, 3, 4, and added these 3 to it. 1, 2, 3 gives us a value of 7. Okay? But if I take a look at negative 4 and 3, what could we do with those values though? Because you have 4 and negative 3. If I add those together, I get negative 1. That's the problem we run into. Take the absolute value of both of them. So you're going to take the absolute value of both of them and then what? Then add them together. Okay, that's another method of madness of being able to do that. Okay, so you have different ways of dealing with this. If I take a look at a number line, I can just count up. This number of spaces, 1, 2, 3, 4, 5, 6, 7 spaces there. That's correct. But if I take a look at both of those things, if both of them are correct, they're both correct, I don't want to have to add additional processes to solving a problem. That I have to remember to do this, I have to remember to do this. Logically, I'm thinking that we can work ourselves through a lot of these problems. But mathematically, we want to be able to do things that are a little bit more consistent because we will continue to come back to each and every time. Okay, so if we take a look at what we have here, I have a value of 3 and I have a value of negative 4. Obviously, if I go 3 plus a negative 4, I'm not going to get the 7. Okay, if I add those two together, I'm not going to get the 7. But if we take the 3 and we subtract off the 4, if I take the 3 and subtract off the 4, now I have minus and negative. Got a little boom ching action going there. Okay, a little boom ching action. I have minus and negative, which turns us into a positive, which is a value of 7. So to be able to find values, we can take absolute values and we can add them together. We can do a bunch of different things. But what we can also do is just subtract the two numbers. When I'm trying to find the distance between two distinct points or two distinct numbers, I can just subtract the two values. What this will refer to, and this will help us out on eventually, is when we get to the idea of a delta. And we're dealing with slope. We take our delta x, which is x2 minus x1, because what we're trying to do is we're trying to find the distance between two distinct points. When we have a delta temperature, when you're in science class, you have delta T. And you subtract your two temperatures. That's the change. That's if I have 40 degrees and I have 70 degrees, what's the difference between 40 and 70 degrees? Well, it's 30. How do I get the difference between my delta temperature? I can take 70 minus 40. So when I'm trying to find the difference between the two or distance between the two, I want to look to try to subtract them. Yes, mathematically we can do different things that works in our brain. But what we need to do is try to be a little bit more consistent, so it's something that we will always continue to refer back to. So if I subtract my two values, I can come up with my distance between the two distinct points. Now, what we could do with that is we can look at also the absolute value of it, the absolute value of the subtraction of the two values. So by definition, our distance between two distinct points is the absolute value of the subtraction, just in case it comes down to a negative. If I subtracted negative 3 minus 4, I get negative 7. I take the absolute value, I get a value of 7. Because what's going to happen now is what's going to, when I throw this into a second dimension. X is 1, y is 2, x is 4, y is 6. What I want to find is I want to be able to find this distance between these two distinct points. Once again, if I'm just talking about horizontal, I can subtract the two x values or subtract my two values. Or if I'm talking about vertical, I can just subtract my two values. But when I'm talking about an angle, now I don't have spacing for an angle. I want to still be able to calculate my distance between these 2 points. Well, once again, what we can do is what we did in the previous problem. We can draw horizontal, we can draw vertical lines. If we draw horizontal and vertical lines, what do we form there? A right triangle. We have a right triangle. If we have a right triangle, we have our good old buddy Pythagoras. Maybe. Where'd you go? There you go. Come on. He's being a little shy today. There we go. He's just being shy. He's at homecoming camp over the weekend. Got a little embarrassed. He's a little shy. He was out in 110 down there. He's got a little embarrassed. People are making fun of his beard. But what we have is our good old buddy Pythagoras. Our good old buddy Pythagoras says that we can use lengths of sides of the triangle to be able to calculate the length of a hypotenuse. Well, if I take a look, I'm starting a value of 1 and I'm going to a value of 4. Starting at 1, going to 4. The length of my horizontal leg here, Emily, is a value of what? Is a value of 3. And we can take our 4 minus 1 to give us this value of 3. Subtracting my two numbers. My vertical line. If I look at my vertical, Cole, what's the length of my vertical leg? A value of 4. And we can take our 6 minus our 2. Because we're going to go up a 6, we're going to subtract down to 2. So we can subtract our 2 y values. 6 minus 4 or 2 to give us a value of 4. Okay, so we have two legs of a triangle. We have two legs of a triangle. Hopefully we can find the third side, which is the hypotenuse. Or if we know our Pythagorean triples, Justin, what do we have? The value of 5. Where we have 3 squared plus our 4 squared is equal to this distance squared. So we have 9 plus 16 equals d squared. 25 equals d squared, or d equals 5. Or if you know your Pythagorean triples, we have a 3, 4, 5 triangle here. Well, if we take a look at what we're looking at here, the length of this bottom leg here, I subtracted my two x values, which I'm going to give this a delta x, which is when I'm talking, once again, when we're talking about a delta in the mathematical world and scientific world, I'm subtracting two values. Whether it's a change in pressure, whether it's a change in volume, whether it's a change in temperature, does not matter. Whether it's a change in my x value or my y value. If I look at my vertical here, I want 6 minus 2, which is my subtraction of my two y values. The subtraction of my two y values. So what my distance formula turns into is my distance squared is equal to my delta x squared plus my delta y squared. So I have subtraction to my two x's, subtraction to my two y's. Now what this expands into, how I found my delta x and my delta y, we have d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And if we take the square root of both sides, what this formulates is what is called the distance formula in the algebraic world. Not a huge fan of it. I more or less go into my delta x squared plus delta y squared equals my distance squared. And looking at the idea of Pythagorean theorem. To me, it's a lot easier to look at because the hope is I don't have to memorize another formula. My hope is that I can sit there and think back to, I've dealt with equations of lines for numerous years. I've dealt with slopes of these lines. And we calculated their slope as delta y over delta x. Okay, that was our definition of a slope. Okay, that's how we learned with respect to mathematics how we calculate the slope of a line. Delta y over delta x. Well, how do I find delta y delta x? I subtract my two y's, I subtract my two x's. Y2 minus y1 over x2 minus x1. So the hope is that if you remember these ideas here, you can just translate it into my distance squared is equal to my delta x squared plus my delta y squared. That's my two legs of a triangle. Okay, we have 2 points here. What I want you to find, what is your delta x? What is your delta y? What is your delta x? What is your delta y? What's your distance between your two x values? What's your distance between your two y values? And then calculate your d. Now solutions, I don't want a decimal form. I want it in a radical a simplified radical form. So solution should be in simplified radical form. I don't want decimals. And check your interest somebody around you. Once again, it should not matter if we come down to either delta x and delta y, if you come down to positive or negative, because you're squaring them. And if you're squaring them, if I have a negative 2 there and I'm squaring negative 2, I get positive 4. If I have a negative 5 there and I square negative 5, I get a value of positive 25. If I get a value of 5 there, I square 5, I get 25. So it should not matter if you're having positive or negative when you subtract your two values, because you're squaring those two quantities. And when you square those two quantities, you're going to get a positive value. So it should not matter if you go 4 minus a negative 2, or if you go 4 minus a negative 2, or a negative 2 minus 4. It should not matter, because one's going to give you a value of 6, one's going to give you a value of negative 6. But when I deal with my delta x squared, positive 6 squared or negative 6 squared, hopefully by now we're old enough now that we're not going to make a mistake if I take negative 6 squared and get negative 36. And mathematically, you need to evolve yourself beyond that aspect of, if I square negative 6, I get negative 36, is incorrect. Negative 6 quantity squared, even though my calculator will sit there and go, well, if I type in negative 6 and square that, it gives me negative 6, and the calculator is always going to be right. You did not square negative 6. You squared 6 and threw a negative in front of it. Use your noggin. Negative 6 times negative 6 is positive 36. So it should not matter. Once again, it should not matter if I go 6 minus 1 or 1 minus 6. And I get 5 or negative 5. Should not matter which one you have. Radical form, what do you get for a solution in the radical form, Sean?
D equals the square root of 61.
Square root of 61. That's correct. We have 5d squared equals 5 squared plus a 6 squared. Or if I have negative 5 squared, negative 6 squared, does not matter. I get 25 plus 36 or 61. Solutions need to be in simplified radical form. Don't want decimals. This big boy, big girl mathematics. Give me it in radical form. Simplify the radicals out. Questions you have? All right, you have about 5 minutes here. I have a worksheet. You're just finding with midpoints. You're finding distances between points. Solutions have been provided for you. Rest of the time is yours.